Hello guys, welcome to Hack with Infy webinar part 2. In the previous part, we have seen a question called special primes, and also I told you that we have not seen the efficient way of writing, of solving special prime. There is a algorithm paradigm called digit dynamic programming. Digit dynamic programming comes under dynamic programming. So using that algorithm paradigm, we'll be able to solve special prime with utmost efficiency, for which I'll be coming with one more part for the same problem using digit dynamic programming. Okay, in the meantime, we'll be starting part 2 with two problems called as paper sheets and break the waffles. Initially, we'll be starting with the problem 1, which is paper sheet, which has been asked in the 2020 Hack with Infy problem set. Coming to the problem statement of paper sheets, I'll just read out the entire problem statement, then I will explain you separately. Sam is given a rectangular paper having dimensions h cross w, where h defines the height and y is the width. W is the width. H is the height and w is the width. Sam wants to fold the paper which is of dimension h into w, so its dimensions are h1 into w1 in the minimum number of moves. The paper can only be folded parallel to its edges, and after folding the dimensions should be integers. Okay, so this is the problem statement. Okay, I'll explain you about the problem statement by taking an example. For example, there is a paper which is given, which is having height 8 and width 4. Now we want to fold the paper until the dimension of the same paper which is having height 8 and height width 4 have to be converted to height 6 and width 1. They are giving you a paper of some certain dimension, and they are asking you to convert the same paper into a different dimension. So given dimension is h and w, converted to be converted, okay, to be converted dimension is h1 comma w1. So always h1 comma w1 will be less than or equal to h and w, because you cannot expand the paper but you can shrink the paper. First, fold along the long edge 6 units from a side. See, I'll just tell you how we are going to convert the paper, how to convert the paper with dimension h8 and w4 into 6 and 1. Okay, we'll see a demo of how to convert uh, the paper of dimension h into w to h1 comma w1 by taking a demo. See, if you look at this, I have just boxed a certain part of this Excel sheet. So here, if you see here, 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the height, 8 units, 8 unit height is there. Okay, 8 unit height. What is the width? Width is 1, 2, 3, 4, 4. So h is equal to 8, which is original height is 8 and original width is equal to 4. And we should convert this into h1 equal to 6 and w1 is equal to 1. Okay, how to convert this? First of all, we will concentrate on the height conversion. Okay, how much total height is? Total height is equal to 8. This total height I should convert it into 6 by folding the paper. So what I can tell you is that we can fold these 2 unit of height inside. Okay, we can fold it inside along the row inside. So when you fold these 2 rows inside, what will happen? These 2 rows will hide inside. When you fold a paper, you can imagine when you fold a paper, the part that we are folding will go inside and it will hide inside, hide with the sheet. So when you fold these two parts, actually when you fold these two parts inside, automatically outside, for the outside world, only these six faces will be visible. These two faces will not be visible because it has been folded and it has been hidden out. So what is the present height? The present height is 1, 2, 3, 4, 5, 6. Okay. By doing only one fold, it is not you have to fold only one unit of row or one unit of column. You can fold any unit of row, and you can fold any unit of column. But you should be converting 8 into 6 in a minimum fold. Minimum fold. That is what minimum moves they were. Minimum moves they were pointing to. So in minimum fold, you have to be converting it. So only one fold. In one fold, you will be converting the height 8 to 6. Okay, fine. Now let us concentrate on width. Now the present width of the sheet. The present width of the sheet is 4. 1, 2, 3, and 4. Can I directly convert 4 into 1? I will not be able to do. Just tell you the reason. When you have a sheet like this with a 4 unit of width, for example, let me consider that I'm folding only this one width. If I'm folding only one width inside, what will happen? Remaining 3 width will be there. 3 width. Okay. If I try to fold these 2 unit inside, what will happen? 2 unit, this unit will be hidden in this inside this row, and this unit will come to this side and it will be hidden here. Can you able to just imagine that it is folded inside? If it is folded inside, this will hide in this. This will merge with this face. It will be merged with this column, and this column will be merged with this column if you are folding it rightward. If you are folding these two parts. Suppose if you are folding these three parts, if you are trying to fold these three parts, then this part will merge with this row, and these two parts have nothing to be, it has nothing to merge itself. So it will be visible on the other side. These two faces, these two columns will be visible on the other faces. You can just imagine when there is a 4 unit width paper is available, when you try to fold these 3 unit of unit width, then this width this width will be merged with this one, and remaining two parts will come to these two places where no paper is there. So automatically what will be there, this row also will be visible, these two rows also will be visible. So if you try to fold 3 unit, automatically the visible unit also will be 3, the width will become 3. So what the maximum you can do? What is the maximum that you can do? The maximum that you can do is half. If 4 is the width of the entire paper, then only you will be able to fold 2 unit, half the unit. 4 divided by 2, 2 unit. Then only these 2 unit will exactly merge with these 2 units. Suppose if you are trying to fold more than h divided by 2 or w divided by 2, it will lead to a greater dimension of paper. So to convert from 4 to 1, first of all, I should fold these two parts, half of the paper unit available, to make it 2 units. So only these 2 units are now available. Now in this 2 unit, you can fold one more time. So this one will be folded inside to finally give only 1 unit of width. So now how many height? What is the height? Height is 6, and with this only 1. So you are having h1 equal to 6, w1 is equal to 1. So how many fold we did? For converting H to H1, we took only one fold. But for converting W to W1, first of all, with the 4 is folded to 2 unit, then 2 unit is folded to 1 unit. So 2 fold we took. So 2 plus 1, totally we are taking 3 folds. We are taking 3 fold. Okay, fine. So both the units are now, if you see, both are actually even number. Now let me convert this height into 9 to make it an odd number, and let us check. So height is increased by 2. So let me just change the color of all these things to green color. So now one height is actually increased. When the height is increased, for example like this, I'll also just fine. So now the total dimension is actually 9 cross 4, 9 cross 4. Now if I want to convert my 9 to 6 or 9 to 4, for example, 9 to 4, what have to happen? First of all, if I try to fold these two unit, if I try to fold these two unit of height, then these two unit will be merged with these two units. Those red color marked units will be merged with these two units. And if it is merged with these units, then the total height will be 6. But the resultant height that we wanted is 4, not 6. Okay, fine. Now, let us try to fold 3 units. If we try to fold 3 units, then these 3 units will be merged. So if these three units are merged, what is the resultant height? 6. No, we want 4. Okay, let us try to take one more unit to fold actually. So let us fold 4 units together. When we fold 4 units together, this will merge with the 1, 2, 3, 4. These 4, it will be merged with these 4 unit. What will be the resultant unit? 1, 2, 3, 4, 5. These 5 units will be visible. Okay, now, okay, but we wanted 4. So let us try to add one more unit. If I try to add one more unit, what will happen? 1, 2, 3, 4, 5. So when you're having 5 unit to be folded, then you have remaining things are 4 only is there. So these 4 unit will be merging with these 4 unit, and the remaining 1 unit will come here. The remaining 1 unit will come here. So now when 1 unit is occupying extra space, what will happen? The amount of visible surface will be 5 unit again. Until 4 unit, it is okay, it is reducing. But when it is changed to 5 unit of folding, then the remaining part you have is also 5. You can just take a paper and imagine. Okay, I will not be, I'm not able to show you it visually actually. But if you try take a paper and if you fold and check, you will be you'll be knowing it. If it is an odd number, then you will not be able to fold it half, because 4 is an even number, so you folded it 2 units into 2 unit. If the original height is 10, you can fold it into 5 unit. 10 divided by 2. If the original height of the paper is like 30, then you can fold it to 15 unit. But here the height is actually 9 unit. 9 unit cannot be, they have clearly given you that it should not be folded in the only after folding the paper. The dimension of the paper have to be integer. So I cannot fold it like 4.5, 4.5. I cannot fold it, because they are asking for us integer dimension. So the maximum that I can do is 5. 4 folding I can do. If I do 4 folding, the remaining 5 unit will be visible. If I do 5 folding, remaining 5 unit will be visible. That we need to understand. Okay, fine. So if 9 is the unit, H unit, first of all I should be folding only 4 units. If I fold 4 units, if I fold 4 units, then these 4 units will be merged and total visible faces will be 5. Now one fold, after one fold, 5 faces is visible. Now again you can make one more fold separately to make it a dimension height of 4. So how much fold you take? 2 fold. 9 divided by 2, I'm taking seal division. 9 divided by 2 have to be 4. If it is a floor division, if it is a seal division, then 9 divided by 4 have to be 5. So 9 divided by 2 have to be 5. So 9 divided by 2, 5. Still we have not achieved 4. So what we can do? Again we can fold it 1 unit to get 4. So what is the strategy that I'm just telling you is that take a height. For example, height is equal to 30. If I want to convert this height to actually 5, what we are going to do? Take a paper of height 30, fold it half. When you fold it half, you will be having 15. Height will be 15. This 15 is not still less than or equal to the height that we want to attain. Okay, we will go for further folding. 15 can be folded to give what? 15 is an odd number. So if we divide it by 15 by 2, you'll be getting 7 if it is a floor division, but 8 if it is a seal division. So 8, still it is not 5. So 8, what we will try to do is we will again fold it half. When we fold it half, we will get 4. So when we keep on dividing it by 2, seal division, not floor division, we keep on dividing it by 2. At some point of time, our H will become less than or equal to H1. There we can stop and we can say that these many steps. How many steps? 1, 2, 3. 3 fold is taken to convert H into H1 threefold. So we are going to divide it by 2 every time. We are going to divide it by 2. Okay, fine. Similar, the same thing is applicable for W also, width also. Take the respective width. For example, 25 you want to you are going to take 25 and you are going to convert it into, for example, 10. So 25 is a odd number. So you have to do seal division. So 25 divided by 2 will be 12 if it is a floor division, but 13 if it is a seal division. Still we have not achieved 10. So this is also an odd number. So we have to again go for seal division. 13 divided by 2 have to be 6 if it is a floor division, but it is going to convert it to 7 if it is a seal division. So now 7 is actually less than or equal to 10, which have to be attained. Okay, original width is equal to 25. The width I should be converting it to, the width I should be converting it to is going to be 10. So if W has become less than or equal to W1, we can stop. How many steps taken? 1, 2. So twofold. So here totally threefold, here totally twofold. Together it is going to be fivefold. So the minimum fold that is going to be taken is going to be 5 folds. 5 folds going to be taken. Okay, fine. So now the next thing that I'll be showing, I have to show you is, so we have seen an example of it. So now what we will do is we will just take the editor. We'll go to editor and we will start. We just let us start solving this problem. So if you see totally, we will be seeing three methods. Three methods I will be proposing here. And in these three methods, we are now have seen only one method of it. And we will implement this. Then we will go a little bit efficient than this. Then we will go to the utmost efficiency. So first of all, what we have to do is I'm going to declare four integers h, w, h1, w1, whereas h is the initial height and h1 is the expected height. W is the actual height by width and w1 is the expected width. So we have taken four variables to store the dimension of the papers. Now I'll be using a scanf statement to receive all this input from user by writing four format specifier %d, comma ampersand h, comma ampersand w, original height and width, and then ampersand h1, comma ampersand w1. Okay, fine. Now we are going to write a function which is going to return an integer value, which is the minimum moves required, minimum fold required. So it is going to return you an integer value, whereas the function name is minimum fold. What information this minimum fold required? It need to know the initial height width and also the final height width also, width also it requires. So we'll be passing four parameters: int height, int the width, and then integer h1 and integer w1. Okay, fine. So now coming inside this minimum fold function, now what we will be doing is that I have already told you what we need to do. We have to start our process from height and we should start dividing it by 2 every time. That to seal division, we should be performing seal division. After performing seal division, we should check every time whether the height is less than or equal to h1 or greater than or equal to h1. You can able to see here. We start dividing your h by 2 every time. At some point of time, your h becomes less than or equal to h1. So when it is less than or equal to h1, you can stop the process. So when you can continue it, if h is greater than h1, you keep on dividing it by 2. The similar is applicable for width also. So coming here, I'll just start writing. First of all, I will take a variable called count to count the fold that we are going to do. So let me write a while loop where h, if h is greater than h1, it need to be folded further. If the original height is greater than the height that you want to achieve, then you should keep on folding it. Okay, so this loop is going to fold the paper, carry out the process of folding a paper. So when original height is greater than the height that should be attained, we are going to do seal division. That remember very well, we are going to do seal division. Okay, so first of all, what we will do is we will Hutch mod. See, first of all, we have to be dividing it by 2. So Hutch divided by 2. When Hutch is also an integer and 2 is also an integer, the quotient that we will get by dividing integer with the integer, we will get a integer quotient. But we don't want an integer quotient, we want a float value, and then we want to seal it. Okay, so now what we are going to do is H divided by 2. So either one of the things have to be float to get a float answer. So 2.0. I'm just converting the divided into divisor into 2 point, I mean a float number. Okay. Now after dividing these two numbers, there is a function called seal. Inside math.h, we have a function called seal. Okay. See one thing. So this is not float. I'll just tell you. By default, when you are providing 2.0 or any decimal point, until it is stored in a float variable, it will be a double data. Until you store it in a float variable, it will be a double data. So you are dividing an integer by a double data. So the resultant answer will be a double. That double answer only you are going to seal it. So the sealed answer, what you are going to do is we are going to check that sealed answer. What we are going to do is sorry, we are not going to check. We have a sealed answer. That sealed answer have to be again stored back in the original Hutch itself. So Hutch is equal to seal. After sealing, it will be a double. See, if you see here, the seal function is accepting a double argument. It is returning a double argument. You can able to see in the tooltip. But we are returning a double, but this Hutch is actually a integer variable. So while you are storing it back, please typecast it back and store it. So we are dividing Hutch by 2 and we are sealing it. When we seal it, we will be getting a double answer. That double answer, again, we are typecasting it into an integer and then we are storing it in the same height variable. Whenever we divide it by 2, it means that we are folding it. Whenever we are dividing it by 2. Whenever we are dividing it by 2, we are folding. So when we are folding, we have to increase the count to know the number of folding that we have done so far. The same process is also applicable for W also. So instead of Hutch, I will change it to W. H1, let me change it to W1. So wherever Hutch is there, we will be converting it into a W. So W. That's it. Now together we will be having a final count value. We'll be having a final count value. That count value, I'm going to return it back to the main function. So what is this count value? This count value will tell us the minimum fold that is required to convert a paper with a certain dimension to another dimension. Okay, now let us take a variable called answer and let us call the function minimum fold of passing height. Okay, what is the height that we are going to Hutch comma W comma H1 comma W1. Okay, so now finally we will be printing printf percentage d comma ans. Okay, we will just check by giving the input that we have taken here, sample test cases. So 9 to 4 and 4 to 1, if you have to convert, totally 4 unit. But if you have to convert it from 8 to 4 and 4 to 1, we have already seen the total number of folding is going to be 3. So we will just give both the inputs and check, verify whether it is working properly or not. So now I'm just going to take paper sheets, compilation. Compilation is successful. So let us go for execution. So in the execution, I'm going to provide the original paper height is 4 with this height is 8 with this 4, and the paper should be converted to the width called as uh, 6 and 1. Okay, for 6 and 1, what is the answer? 8 if it has to be converted to 6, 1 fold. If 4 have to be converted to 1, 2 fold. Totally it have to be 3 fold. Yes, it is giving us the right answer, 3 fold. Okay, let us give one more input and check. The original height is going to be 8 and width is going to be 4, and we should be converting it into, so okay, take for 9 as the original height, and 4, it should be converted to 5 and 1. Okay, if it is 5 and 1, we know very well that 9 can be converted to 5 in a single fold, and 4 can be converted to 1 in two fold. So totally again it will be 3 folds. Yes, it is right. Now we will try to convert 9 4 to 4 1. Now 9 cannot be converted to 4 directly. 9 have to be first of all converted to 5, then 5 have to be converted to 4. So totally two fold for height and two fold for converting 4 to 1. So totally you'll be taking 4 fold, minimum of 4 fold to convert the paper of dimension 9 cross 4 into 4 cross 1. So this methodology is working fine. This methodology is working fine. Okay. So now what we will be doing is we are going to optimize it further. We are going to optimize this system further. How? How we are going to optimize this? Division process will be taking, division and sealing process will be taking more time actually. It will be taking enormous time. So in order to overcome the maximum time that is taken by this division process and the sealing process, what we are going to do is, instead of this, I will just tell you here, I'll be first of all checking whether H is an odd number or not. I will not again use mod operation to check whether a number is an odd number or even number, because similar to division operation, mod operation also is a costly operation programmatically. Programmatically, it's a costly operation. So I'm going to use the bitwise operator called AND to check whether a number is a odd number or even number. We already know that the binary representation of an odd number will be having least significant bit as 1. If it is an even number, then the binary representation will be definitely lowest significant bit will be 0. So what we are doing is we are taking a number called 1 and we are doing bitwise AND operation. The binary representation of 1 will be having least significant as 1. So when we are taking least significant as 1 and when we are doing AND operation, if the final answer is 1, then it is proven that the original number is having least significant 1. Because if the original numbers least significant bit is 1, then only that 1 combined with the least significant 1 of the decimal number 1 will combine together to give an answer, resultant answer 1. So if this is equal to 1, if you want to know the reason for this, you can go to basic course which is available in our channel. There I have clearly explained you with the demo. So now here we have no time of explaining you about this operation actually, but I can tell you that this operation will check whether a given number is an odd number or not. This is a condition for checking a number is an odd number or not. Okay, fine. So whenever you are using bitwise operation, then the process becomes very efficient. Because whenever you do division operation, subtraction will happen in between. Okay, many number of subtraction will be happening in the background. But when you're doing AND operation, if for example, if integer is totally 4 byte occupying 4 byte, how many bit will be there? 32 bit. So whatever the number might be, maximum of 32 bit comparison only will be taking place. 32 bit operation only, maximum possibility. So we can call it as a constant operation, bitwise AND as a constant operation, whereas this division is actually exponential operation. Compile, when you're speaking about programmatically, it's exponentially, because you keep on dividing something by again 2 2 2 2. For example, if you are dividing 100 by 2, it will nearly take 50 steps to know the quotient. Okay, so if you divide 10 power 6 by 2, enormous subtraction have to be taken place. So that is why I'm just taking this operation. So if this condition is true, then it is definitely an odd number. If it is an odd number, what I'm going to do is, for division, I'm not going to, for dividing a number by 2, I'm not going to use division operator. I'm going to use right shift operator, bitwise right shift operator. So Hutch is equal to Hutch right shift 1. If you want to know this right shift operation, again, you can just go back to the advanced C programming first video. Okay, to the course called as advanced C programming, which is available as a playlist in our channel. Go to that particular playlist and see part 1. In the part 1, in the first 20 minutes, I have explained to you what right shift operator and left shift operator will be doing. Right shift operator will be dividing a number by 2 automatically. If you want to know the inside process, you can go back to that video to understand it. So instead of dividing a number by 2 using division operator, we are dividing a number by 2 using right shift bitwise operator. Okay, and after dividing it by 2, for to make it a seal, I'm not going to use seal function. I'm going to add the value. I am going to increment it by 1. Okay, if it is an odd number, definitely you divide it by 2, it will be floor division. So if you add 1, it is automatically converted to seal division. For example, if 11 is divided by 2, I will get 5. If I want to seal it, I have to add 1. So 5 plus 1, 6, sealed division. So I'm dividing it by 2, then adding 1 to it to make it a seal division. Okay, fine. Else, suppose if it is not a odd number, what I will do? I will not increment, I will not seal process. Just simply what I will do, if it is 12 divided by 2, 6. No need of sealing process. So Hutch is equal to Hutch right shift to 1. Okay, either if or else, no matter whatever it is, we will be incrementing the count to know the fold that we are going to do. So even if it is if condition or else condition, whether whatever the condition might be, but if you enter into this while loop, definitely you have to make a count that whenever you enter inside the loop, automatically you will be doing at least one fold of the paper. The same process have to be done inside our while loop also. So let me copy down all these things and let me paste it inside this while loop. Whatever we are seeing is method 2 of solving the same problem, method 2. Okay, so now coming to this one, let us change all the Hutch into W. So that will do the same process. Okay, I think I need not to explain it separately for width, because the same process that we are doing in the height, I'm just doing it in the width side also. Okay, fine. So now finally we have to be going with the final count. So again, now what we will do is we will just try to do the same process again and again to check whether this is working or not. Okay, so I will just go for execution. Initially the paper height, let us consider as 8 cross 4, and we have to be converting it into 6 cross 1. So totally we'll be taking 3 fold. This we already have seen here. You can see here 8461, it will be taking 3 fold. Okay, the next thing that we can try 9451. So we will just again try with 9451. 9451, again it is 3 fold. Now coming here to 9451, 4 fold. 9441, it is going to take 4 fold. So again it is working in the same way. So no changes in the logical terms, but we are changing it in the implementation terms to make it further efficient. So we have taken all the division operator, seal function, and we have converted the entire program using only bitwise operations. Bitwise operators only have been used. Okay, fine. So before going to the next method, if you have any doubts on the right shift operation and the bitwise AND operation, I'll just explain you both those things and then I will move to the next method. Okay, fine. So for example, what I will do is I will take first of all, we will finish off the AND operation, which is checking a number, whether it is an odd number or even number. So first of all, I'll just take all this, for example, 1 2 3 4 5 6 7 8. Okay, I'll just take 8 bits. I'll take these 8 bits. So let us just take 10 and let me convert it into, see, first of all, I'll just show you something. For example, let us start from 10, 11, 12, 13, 14, 15, 16, 17. What is the corresponding binary representation of 10? It is 1010. What is the binary conversion, binary value of 11? It is 1011. What is the binary representation of 12? It is 1100. What is the binary representation of 13? 1101. Binary representation of 14? 1110. 1110. Binary conversion of 15? All ones. Okay. What is the binary representation of 16? 1 4 zeros. What is the binary representation of 17? 1301. So I have taken few numbers and I have also written the binary corresponding binary representation of those numbers. So if you keep on observing, 10, 12, 14, 16, all these numbers are actually even numbers. All the remaining unselected numbers are odd numbers. So if you concentrate on the binary representation of the even numbers, the last bit, which is low significant bit, last bit is 0. For 10 also it is 0, for 12 0, for 14 0, for 16 0. For all the remaining odd numbers like 11, 13, 15, 17, the last bit is actually 1. If you observe, you can able to check it. Okay, understand it. Okay, if you're able to observe this, you'll be able to observe this to understand it. Okay, fine. So it is clearly understandable. It is clearly understood that if a number is an even number, then the lowest significant bit, low significant bit means last bit, right word bit, will be 0. If it is an odd number, then the lowest significant bit will be 1. Okay, now let us take a number called as 1, decimal number called 1. What is the binary representation of 1? Zeros followed by 1. Only the lowest significant bit is 1 for the binary representation of 1. Okay, so now what I will just simply do is, I will take a number called 13 for example. 13 means 0, 0, 0, 0, and it is 1, 1, 0, 1. So it is enough that if we prove if we prove that the last bit is 1, then it is definitely a odd number. If we prove that the last bit is 1, then it is definitely an odd number. So what we are going to do is, I'm going to take a corresponding binary representation of 1. So 0, 0, 0, 0, all zeros, and only the lowest significant bit will be 1 for the binary representation of 1. Now let us do what AND operation. What is bitwise AND will do? What bitwise AND will do is, it will check bitwise. It will check each and every corresponding bits, and if both the bits are 1, the resultant answer will be 1. Like a AND gate in EC. If you are EC student, then it will be very easy. You will be very familiar with the AND gate operation. What is the nature of AND gate? If both the inputs are 1, then the resultant answer will be 1. If at least one of the input is 0, then automatically output also will be 0. So if the original number's last bit is 1, then definitely the AND operation will be providing the resultant answer 1. Lowest significant bit will be 1. All the remaining other bits will be 0, because the binary representation of 1, all the other bits are 0. I told you AND gate means at least if one of the bit is 0, all the other bits, the resultant answer is 0. So we know very well that all these bits are 0 in the binary representation of 1. So definitely all these answers also will be 0. So when you take a number and when you do bitwise AND operation with 1, and if the resultant answer is 1, it is proven that the last bit of the lowest significant bit of the original number is 1. So that is what I have done here. Taken the number, I have done bitwise AND operation with 1. If the resultant answer is 1, then it is definitely a odd number. This is what I was trying to do there. So this is what they use. So suppose if the answer is 0, then definitely, if it is a 0 bit, then definitely the answer also will be 0, because one of the bit is 0. So when the resultant answer is 0, definitely original bit is 0. Then only that is the reason why the answer is also 0. So if the resultant answer is 0, it is proven that the lowest significant of the number is 0. If the resultant answer is 1, then it is proven that the lowest significant bit of the number is 1. So using whether the lowest significant bit is 0 or 1, we will be able to detect whether a given number is a odd number or even number. So this is a very efficient way of finding a odd number or even number case, which we have also implemented there. Okay, fine. So the next thing is, I should also show you the right shift operation. For example, let us just consider by taking the binary representation of 64. What is a binary representation of 64? 1, 0, 0, 0. Yeah, this is the binary representation of 64. So this is the binary representation of 64. So when you do a right shift operation, what will happen? When you do a right shift operation, then all the bits should be right shifted by one position. So let us start from the most significant bit. This most significant bit should not remain in the same position. It should be right shifted by one position. So this one have to come here. One right shifted. If it is one right shifted, what will come here? We should be starting it with the 0. Whenever you do a right shift operation, starting position should become 0 and the first bit should be moved to the second bit. Then this 0 bit will be moved to this position, right shift. This bit will be right shifted by one position. This bit right shifted by one. This bit is right shifted by one. This bit is right shifted by one. This bit is thrown out of the scenario. Now, what is this binary representation? The binary representation of this number is actually 64. What is the binary representation of the new number that we have got? It is 32. This is 32. Okay. Let us try to make one more right shift. If we are making one more right shift, what will happen? We will start with the 0 and this 0 bit will come here. This 1 will be right shifted to one position. 0 will be right shifted here, this position. This 0 is right shifted here. This 0 is right shifted here. This 0 is right shifted to this. Now, what is the binary representation of this new one? This is 16. Can you able to see it here? 64, 32, 16. So whenever you do a right shift operation, the original number is keep on divided by 2. That is what I'm just trying to say. Whenever you do a right shift operation, the original number is divided by 2. That is the main reason. Instead of division operation, I have introduced you to right shift operation. So what will happen when you do left shift? When you do left shift, opposite, contrast, multiplied by 2 will happen. So when you do left shift operation, 16 will be converted to 32, 32 will be converted to 64. So you keep on multiplying by 2. Now you are keep on dividing it by 2. Now when you start doing your multiplication, left shift operation, automatically multiplication by 2 will start taking place. So these two reasons are mainly responsible for this. Okay, fine. Now let us go to the final method. So in three methods, we have seen method 1 using mod operation and seal function. Method 2, the same logic of first method, but we have now implemented it using bitwise operation. Now we will be seeing method 3. What is method 3 going to be? Method 3 is going to be the very efficient way of doing it. Okay, see, our primary task is to divide the given input by keep on dividing it by 2. Okay, so I will just introduce you to something called as logarithm. What is logarithm? For example, I will just take a number called 64 here. Divide 64 by 2, you get 32. Again divide 32 by 2, you get 16. 16 by 2, we get 8. 8 divided by 2, we get 4. 4 divided by 2, we get 2. 2 divided by 2, 1, we get 1. So start with a number called as n, for example. Start with a number called n. Keep on dividing that n number by keep on dividing it by 2 until it reaches 1. Okay, now how many steps are required to convert it into a 1? Convert the given number into 1 by keep on dividing it by 2. Step number 1, step number 2, step number 3, step number 4, step number 5, step number 6. How many steps required? 6 steps are required. So I will tell that log of 64 base 2. What is base 2? Because you are dividing it by 2, right? So that division 2 is responsible for base 2. So log base 2 64 will give you answer 6. What is 6? The number of steps required to convert it to 1. This is what generally logarithm is about. What it's all about. Start with a number, keep on dividing it by 2. At some point of time, you reach 1. The number of steps that you require to convert a given number into 1 by keep on dividing it by 2 is what called as log 2, log base 2. Suppose you start with a number and if you keep on dividing it by 3 to reach 1, then it is called as log base 3. So whatever you are dividing with consistently is going to be the base value here. So here we have divided it again and again by 2, so base is 2. Okay, what to do with the logarithm here? What is the purpose of logarithm here? Because we wanted to know how many steps it requires to convert a given number to another number by dividing it by 2. Am I right or wrong? We take 9, we divide it by 2 to get 5, and then we divide 5 divided by 2 to get 3, where this 3 becomes yes, this 3 becomes less than 4, so we stop the process. So we start with a number and we keep on dividing it by 2 until it reaches a particular number. Little bit similar process, right? Little bit similar. Here we are starting with a number, we keep on dividing it by 2 until we reaches a number called 1. Here also we start with a number, we keep on dividing it by 2, but here we are not reaching 1, we are reaching to a some random value, h1 value. How we are going to take this logic and we are going to apply it for this case? Yeah, I'll just tell you the logic. For example, we have to convert 64 into 16. We have to convert 64 into 16. Okay, now tell me what are the number of steps required to convert 64 to 16. First of all, we will write. First of all, we will take 64 divided by 2, we get 32. Divide 32 by 2, we get 16. So how many steps are required to convert 64 to 16? Only 2 steps required. 2 steps required. Okay, now we will find logarithm of 64. What is logarithm of 64? Logarithm of 64 is we are going to take 64 and we are going to keep on dividing it by 2 until we reaches 1. So 64 divided by 2, 32, 32 divided by 2, 16, 16 divided by 2, 8, 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1. How many steps required? See, here in this case, we require actually 2 steps. Here in this case, step 1, 2, 3, 4, 5, 6. So totally, see here, totally we require 2 steps. Here we require totally 6 steps. Okay. This logarithm of 16. Converting 16 into 1 by keep on dividing it by 2 was called as logarithm of 16. So 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So how many steps required? Step 1, step 2, step 3, step 4. So the total steps required is actually 4. Okay. What I'm trying to say is that if you want to find the number of steps that you require to convert a number to another number, find the logarithm of this number, find the logarithm of this number, subtract both this. So logarithm of 64 is 6, logarithm of 16 is 4. So when you subtract both the steps, you get 2. That many number of steps you require to convert a number to 16, 64 to 16. In between steps, see, you want only the in between step, conversion from 64 to 16. That in between terms only you require. For that, what you can do, you can find the entire steps that is required to convert 64 to 1, and then you can find the number of steps required from 16 to 1. So when 64 to 1 steps and 16 to 1 steps is subtracted, then you will get how many steps are required to convert 64 to 16. Am I right or wrong? So normal logic, mathematical logic. So what we are going to do, we are going to find the logarithm of height and logarithm of height 1, and we are going to subtract it. Okay, we are going to subtract it. Fine. So, and also further we have to do a seal operation. Seal operation. Okay. So here we cannot do +1, we cannot check odd number or even number, and we cannot add 1. So here we have to definitely use a seal function. But only one time only we are going to use seal function, right? in the previous methods, if you see here, in the previous methods, we have, if we are using ceil function inside, how much time until this while loop finishes, that ceil function will keep on doing that. That too for height also separately and for width also separately. So ceil operation is performed for many number of time. That is why we got rid of ceil function. Now using we are going to, I'm going to just convert this methodology. I'm just convert this methodology to logarithm. How to find logarithm? Already we are having that inbuilt function in math.h, so don't worry. So what we are going to do is, initially I'll be finding int h is equal to, sorry, not h, int h, because already h is there. So h is equal to log2 is the function, log2 of, see, you want to give a double as argument here in the tooltip. If you are able to see that the argument should be a double, but our argument is actually integer. So what we can do, we can do typecasting. So typecasting means, first of all, we have to specify the data type to which we have to convert, then followed by the variable. So h. So h is converted to double, then it is passed as an argument for log2. Then the resultant answer have to be again stored back, right? So if you want to store the resultant answer, what answer? Ceil answer you have to store. So find the ceil answer. So ceil of log2 of h. Ceil, first of all, typecasting will take place, then log operation will take place, then ceil operation will take place. And after doing the ceil operation means you will be getting a double. That double have to be converted to integer and again stored back, because it is an integer variable, or otherwise some conflict might happen. So I'm going to convert it into an integer. So I'll just give the data type that which have to be converted to. The same methodology I have to use for h1 also. h1. So instead of h, let us convert it into h1. That's it. So now what I should be doing is, I should be subtracting h and h1. I should be subtracting h and h1. So h and h1, if I subtract, it will be giving us the total fold that will take to convert h to h1. Okay, so see what I, okay, fine. So we will do it finally. So first of all, we will finish with the width also. So w is equal to, again, the same process we are going to do for w. And then for w1 also, what we will do is, we will do the same process for w1 also. Fine. Now what we have to return back, h minus h1, you will be getting a number of fold that required to convert h to h1. Then subtract w and w1, you will be getting the number of fold required to convert w to w1. Add both the fold. So you can return h minus h1 plus w minus w1. This is the answer. This is the number of fold to required to convert height to h1, and this is a number of fold required to convert w to w1. Now the same process. Okay, so now I'm just going to take, we'll be executing yeah, paper sheets, and let us go with this. So let us again try the same inputs, 8 4 6 1, giving us 2, 8 4 6 1. Okay, we will, 8461 is giving us 2, so we will just okay, if you see a small mistake, that is the reason here. What's a small mistake is, we have to subtract and then only we have to go for the seal process. Actually, we are sealing it, then we are subtracting it, but we have to subtract it, then only we have to go for the sealing operation. So what we will do is better, I will write h is equal to, once again I'll just write log2 of double of h, I will take it, then subtracted by h1, log2 of double of h1. This part we will subtract, and now the whole part can be, after subtracting, the whole part can be now sealed. So seal operation, and after sealing, the corresponding, it can be converted to a integer type. Okay, the same process have to happen for width also. So w is equal to W is equal to, I'll just get rid of this. So W is equal to the same expression. Let me copy and paste it here. But instead of H, we have to be going with W and W1 and W1. Okay, fine. That's it. So now we are not going to do this operation. Just we are going to simply add H and W. So H plus W. We are just simply going to add H and W. Okay, so now we will just go for compilation and also we will go for execution, whereas we have to convert 8-4 conversion to 6-1. So when we'll be taking threefold, yes, it is working. We will also try one more thing like 9-4-5-1. So for converting 9 to 4, 1 unit, for 4 to 1 it is 2 unit, totally 3 unit. Yes. So then coming to 9-4-4-1. So for converting 9 to 4 we take 2 fold, and for 4 to 1 we take 2 fold, so totally 4 fold we take. Okay, this is also working fine. So this is a, because we have used only two equations. So for see, for using, for converting log to equation, subtraction, simply no loop is provided here. Okay, so this is actually a order of one solution, constant time taking solution. Okay, so this is the efficient of all the three. So method 3 is using logarithmic technique. So using logarithm we have completed the method 3. So we took a problem called as paper sheets. We have seen, we have taken a problem called paper sheet. Okay, so whereas if you see the problem statement of paper sheet, Sam is given a rectangular paper having dimension h into w, where h is the height and w is the width. Sam wants to fold the paper, so its dimensions are h1 cross w1 in the minimum number of moves. The paper can only be folded parallel to its edges, and after folding the dimension should be only integer. So we took a problem statement called paper sheets, and we have implemented three methods of this problem. Okay, fine. So we took an example and we have finished all the procedures that is done. Okay, so what we will be doing is in the next lecture, we will be covering one more problem called as break the wave waffles. Okay, in the next lecture we will be seeing a problem called as break the waffles. So until then, thank you from Six Phrase MySlate, especially from Sachin. Okay, thank you.